Welcome everybody. In part 1 of our session on how to use Wi-Fi on the ESP32, we looked at some of the basics. Now in part 2, we're going to set up a web server. This we'll do in 3 steps. In the first step, we'll just create a simple basic web server that shows a static page on a client. In the second step, we'll then add Websockets for instant updates between client and ESP32. Then in the third step, we'll add JSON to that to simplify the data transfer. So let's get started. The link for the code is in the description below. So please navigate to the GitHub page and go to code and download zip. As you can see, the code is available for all the 3 steps that we're going to discuss. The simple web server, the web server plus WebSocket, and the web server plus WebSocket with JSON. However, to give you a little bit better understanding how it works, I added as well a Wi-Fi basic, just simple code to connect to a Wi-Fi network as we discussed in part number 1. And based on that, we're going now to develop this code together, and that way you can maybe use it to your own benefit to make your own web pages. So let's get started with the ESP32 Wi-Fi basic. We open it up and open up the .ini file. So the only thing that the program here does right now is you provide your SSID and password and it connects to your Wi-Fi network. Now we need to set up a web server. And we can do that by including Webserver.h. So the next thing we do is that we define an instance of the web server. So that's done by stating web server, we'll call it server, and we'll refer to port number 80. We then go to the setup, and in the setup we will need to initialize the server itself. And we do this by going to server on and defining the root folder. So double brackets for the root here, and we don't want to refer to a function, and that is done with these brackets and these brackets. A little weird, but that's the way you can escape by not having to have a function here. And then we can open up with these brackets, and then we can tell the server what to do in case someone connects to it. So we'll start by sending 200, which is the HTTP response code that the request has succeeded. Then we'll provide an indication that we'll be sending over HTML. And we can then have a web page variable that actually contains the actual HTML web page. So we should of course add that variable over here. And you could really write it like this. So you could start with some HTML and write whatever you want. But I find it really difficult to edit in a single line. You can of course also make multiple lines by going by using this backslash, and then you can add some more code, and you could really add your whole web page like that. And this would work as well. But I actually prefer to just use a real editor for the web page, and then copy pasting it in here as a single string. So to make it easy for you, I included a simple web page as a file in the ESP32 Wi-Fi basic folder. So let's go ahead and open that in an editor. So we just want to have this as a single string. And the simplest way to do that is by compressing it. You can do that online. So if you Google, for instance, compress HTML, there's many different versions. I included one that I used here in the description below. You copy paste the HTML in, say compress HTML, and there you go. You have your single string. We go back to our Arduino code, and then we can here copy paste the string in, and we're good to go. There's one thing I should comment, and that is that I used single brackets here in the HTML code, because if I would have used double brackets, then the Arduino would have thought that the string ends here. If you really need to use double brackets, you can escape them by using a backslash. But I was just lazy and used everything with single brackets. So let's continue with our setup. We just added the web page over here, and now be careful that we close the server on command correctly. We need to do first brackets, and then we'll need to do a semicolon. Then the next one will be server.begin. And the setup should be good to go. The final step would be a server.handle client in the loop. And we should be good to go. Let's see if this compiles. I forgot here to initiate, of course, the web page variable as a string. So let's add that quickly. Sorry about that. In the console, we can now see the IP address. Might you open the console too late and you don't see the IP address, just briefly reset the ESP32 and it will reconnect to the Wi-Fi network and plot the IP address again. We copy paste the IP address into a browser and sure enough, here's our simple web page. As a next step, let's generate some random numbers with the ESP32, just pretend it's a sensor or something, and send that data over to the HTML client. So let's first go to our HTML page. In our HTML page now we want to say random number generator, and we say here the random number is, and at this moment we'll need to split up the HTML because we need to insert here the variable, and without a WebSocket it's very annoying to have to do this. So I'll just copy paste the beginning, compress it. So this ends with the random number is, and we're going to call this now web page section 1, and then we're going to make a web page section 2. And that will be the rest of the web page. Then we have we add our random value. As said, this is a little bit of an ugly patch. We'll make it a lot nicer later on, but we need to just briefly start somewhere. We want to update random values, and so let's make some sort of a time interval. And give the ESP32 a little bit of sense of time. We've done this a million times before, so I'll not go into a lot of detail here. As here in the loop, we now just add a simple check. So we take the current time. That's now. And we just check if now minus previous millis is larger than the interval. And in that case, we want to, oh well, let's use brackets here, make it a little nicer. And only then we should update the random number. And we'll just do that by repeating this particular sentence. We do, of course, need to update previous millis. And that should do the trick. So let's compile. I forgot the equals sign here. Pretty obvious. If I now refresh the page, then you'll see our random number generator, and you'll see that the random number is 15. But every time that you want the number to be updated, you need to refresh the page. And that's pretty annoying because you basically want it to update automatically. As soon as a new number is generated in the ESP32, you want this web page to just show that number without needing to reload all over and over and over again. And that we can do with Websockets. So let's go and implement these. Now for the Websockets, we'll need to load a library into the IDE. And for that, we'll have to go to Sketch, Include Libraries, Manage Libraries. And you'll have to search for Arduino Websockets. Please make sure you search for Websockets with the S at the end, otherwise it won't be found. And then if you scroll down, you'll see a library by Marcus Suttler. And that's the one we're using today. So make sure you click install and have that ready to go. Then we're going to load that library over here. So include WebSockets server.h. And as the next step, we're going to initiate an instance of that WebSocket server. So here we can write WebSockets server, and we're going to call this WebSocket equals WebSockets server. And this one is going to get port 81. That's the standard port for WebSockets. All right, now with these WebSockets, you have communication from the ESP32 to the client and from the client to the ESP32. So let's start with the communication from the ESP32 to the client. And we'll start with our HTML page because that will need to be changed quite a bit. Now, the main thing we want to do is get rid of this sectioning that we had, part 1 and part 2. We're going to do that here by adding a span that we're going to write the value to. So right along, we're going to say that the random number is going to be written in span ID. And we can call this what we want. Let's call it rand from random number. And initially, we'll just write a dash here. And of course, we need to conclude the span. Now, there's quite a lot of JavaScript needed here. I'll speed this section up, otherwise the video would take so long. But we'll discuss the code as it's written. So here's the JavaScript code. The first thing we need to do is make sure that whenever the client window is loaded, that the WebSocket is initialized. So window on load, whenever the window is loaded, we initialize. We call this init function. The init function itself is over here. And there we just create a socket, and that's going to be a WebSocket, and it's going to point at the location hostname IP address and take port number 81. And then whenever a message is received, we need a callback function. So we define here on message a callback function process command, and that callback function is shown over here. And the only thing really it does is that it's going to write in this span ID with identifier rand, it's going to write event.data. So that is the data that it receives through the WebSocket. Just for debug purposes, I show this as well in the console. So in the web browser with F12, you can then verify whatever is written into the console log. So let's now make this work on the Arduino as well. And we'll start by converting it into a string. This time we don't need two parts anymore, just a single string. Here we get rid of that extra sentence. We just need one sentence, one web page, and it's going to be the string we just made. And so let's have a look at the setup here. We can now initialize the WebSocket with WebSocket.begin. That should do the trick. And in the loop here, we need also to update the WebSocket. So we need a WebSocket.loop command. So let's update now this section where we want to write a random value now to the WebSocket. So we won't be needing this statement about the web page anymore. The web page will take care of itself as long as we just post a new value on the WebSocket. So we can write to the WebSocket with the following command, WebSocket.broadcast text. That broadcast goes to all clients. And here we can write then our variable. And that's As easy as that. The one tricky thing though is that this particular function only accepts an array of char values. So we'll just need to create our random number. So we do this random. So we'll do this random 100. But that's going to be an integer, obviously. And we can, of course, convert this now to a string. But that's still not a char character. There probably are smarter ways to do it, but I briefly have this clumsy way of converting it. So it doesn't really matter that this is not the prettiest or cleanest code. As soon as we introduce JSON in the next step, then all this conversion is gone anyways. So let's run this code. So here's our page again. And if I now refresh, then you'll see that automatically every second the random number is updated. This now provides communication from the ESP32 to the client. So let's add some communication the other way. Let's add a button and send some data from the client back to the ESP32. We start here in our HTML code, and now first we want to add a button. So we could do that, for instance, over here. Where's the single ones button? And then ID, we give it, of course, an ID again, and we could call it a button for sending stuff back. Call it whatever you want. And then the button needs a name. We could say send info to ESP32, and we close the button again. So. And the P as well. So that should work. So we have a button now and it needs some code behind it. In HTML, you can work with posts and gets, but I really don't like them. So we'll just do everything in JavaScript. And that's done pretty simply by document.getElementById. And then we just need to refer to the button over there. So that is the button send back. And then we do an add event listener. Tell it what to do. It needs to act on whenever it's clicked. And then we can call a function. Whenever the button's clicked, do a function within JavaScript, and we'll call that, for instance, button send back. All right, hope I got that right. So now we need to only define that function that it needs to run whenever the button is clicked, so that we can send back stuff over the WebSocket. And here we can straight away send something. So let's just send a sentence. Obviously, you can send back any parameter or whatnot, but we'll just send back a sentence here. And that's all for the JavaScript. So let's get this thing loaded into our Arduino code. Now within the Arduino environment, we need to set up a callback function for the WebSocket. And we can do that in the setup. So here in the setup, we can just say WebSocket.onEvent. So whenever there's something happens, call a function. And we can call this function whatever we want, but for instance, we could call it a WebSocket event, because that's basically what it is. And in the bottom here, we can then define what this function should do. It's a void in our case. And This callback function has a fixed header here that you can just take exactly like this. So let's go through the header. The first one, the num, is the client number. So you can differentiate now and see which client sends you what. But we now only use broadcast functions, so we're actually not using this number, client number. The second one is the type of event that you receive. It could be a connect message, a disconnect message, or it could be an actual text message. So we need to differentiate between that. And then there's the actual payload, and that is a pointer to an array of unsigned integers. And finally, the last one is the length of the array, so that you know how many bytes you are allowed to read out. The initial code here is pretty standard and it's pretty much always the same. So I'll just briefly write it up and then let's discuss this. So basically we just switch on the type of message we receive. Whenever it is disconnected, we say this client is disconnected. We could actually also add the number if we wanted to. And then if a client is connected, we say, okay, there is a new client came in and it's connected. You can add also extra code here with the connect or disconnect if you want that. What we though want to do is we want to receive messages from the client. And we can do that now with the third type here, WS type text. This is basically whenever the client sends data to the server, you can receive that over here. You'll receive it here as char values as well. And in order to print, we'll need to convert these then to string some way or the other. Again, I've got a bit of a clumsy solution here, but no worries with JSON. This will be very, very clean. So in essence, what we're going to do is I'm just going to iterate through the bytes and convert each of them one by one. I end here with a serial print ln because obviously I used serial print without the enter to just get all the characters after each other, and then you want to end of line after that. And that's all there's to it. So let's compile and see how this runs. So if I now refresh the page, an extra button will pop up. And that button will send back information to the ESP32. Now we want to be able to see this, of course. So what happens on the ESP32? So we'll briefly have to open the console. So the console is on the right and then the website's on the left. And if I now press the button, send information to the ESP32, then in the console we see sending back some random stuff. And every time we press the button, we see that the ESP32 has received this text. All right, so now we have instant communication between the ESP32 and its clients, and also the client back to the ESP32. But the one thing that's really annoying is this conversion to char values and just passing back and forth variables. And this is substantially simplified with JSON. So let's add that JSON in the third and final step of this course today. So this time we'll start with the Arduino file. And the reason is that we need to now load a new library. For that, we'll go to our Manage Libraries again. And here we're going to search for Arduino JSON. And you see here the Arduino JSON library by Benoit Blanchon. And this is the one you'll need to install. We can then load the library over here. Now, the first thing we need to do to get started is we need to define the memory that the JSON document is going to work in. We can do this by defining it like static JSON document, and you can define here the size, like something like 200 bytes, and you can then give it a name. However, we're going to have a JSON document for sending and a JSON document for receiving. In principle, you can use the same, but just to make sure that there's no instance where the memory overlaps and you get errors, I recommend to just have two different variables. The ESP32 has plenty of memory for that. So we could have a doctx and a docrx. Then let's go to the section where we're sending random numbers. And here the first thing we want to do is get rid of this ugly conversion. Instead, what we're going to do is define a JSON string that we're going to send over. And initially it's going to be empty. Then we need a JSON object. That is the object that we then will later on convert to the string. And we take here the tx, the doctx that we defined, the memory here that we defined. Now we can fill that object. Let me write it correctly though. We can fill the object with variables. And to make it a little bit more interesting, perhaps we should just send over two random variables instead of one. That would be something that would have been tremendously hard without JSON encapsulation. The next step is the most important one. That's where we now convert this object to just one string. And that string can, on the other side, then be converted back to a structure with actual variables. This is called to serialize the object. And as you can see here, for the serialized, the doc is the source and the JSON string is the output. You can, of course, look at this string as well. That's good for debugging, perhaps. And then we can write it to the WebSocket. Okay. Oh, wait. Before we continue, I actually see a mistake here. doctx.to, and then it's the JSON object. So my apologies. And there's another minor thing here. I write here serialized JSON object from doc. That's the variable we usually use, but we said we're going to separate doctx and rx. So this is of course doctx over here, because we're sending something from the ESP32 to the client. That's all there's to that. We now need to receive it on the other side. The process command function is the function that is run whenever data is received. And the only thing we need to do is now define a JSON object here. So this is done as so. The event.data is basically the JSON string in this case. So we just need to convert it back to the actual object. And we can do that with the parse function. Now we can just write the random number directly from the object's memory. So this should do. But we actually now have two random variables. So let's make another span over here. So the first random number is, and then the second random number is, and we'll call them rand1 and rand2. And then obviously here we need to update this get element by, it says rand and it should be rand1. And then we can copy paste this and have the other one be called rand2. And again, for debug purposes, below that you could update the console as well and have that write in the random number 1 and object.random number 2. So that should do for the communication from the ESP32 to the client. Now we want to go the other way around. We want to send back also not just a simple string. We want to be able to send back multiple variables all at the same time. So let's make a structure with some details of my guitar. and send that all back in the same string. So we have here my guitar, and it has a brand. It is a type, there's a certain type, right? And we have a year. I'm not sure when it's bought, so just put in a random year. And then color. Now I've got a white guitar. Okay, so let's send this particular structure back, and we just use this send command. And there's quite a few ways to do JSON encapsulation, but I here use stringify. That should do. Now, of course, we need to be able to receive this data on the other side. So let's go back to our ESP32 code. And here in the text side, we now need to receive this particular data. And for that, we can just run a deserialize JSON command. So here we do deserialize JSON, and this time we're going to use docrx and write the payload in that. And we want to catch whether there is an error or not. And if there's an error, you could print that, right? And you know that something went wrong. Okay, and of course, if there's an error, you want to return. So if there's no error, we can go ahead and we can just print the JSON object. The one thing though is that we need to cast the variables correctly. So there's these are char variables, and then the rest is rather straightforward. And we can do the same for the other variables. Year though is an integer, so we might as well just straight away change this to an integer. And then we can print them. And that should be about it. Now, before we now run this on the ESP32, the one thing that I did forget was to copy the HTML content to our string. So let's go here to the web page string and compress the HTML and run the code. So let's refresh the web page. And now we see two random numbers. We see here that the client just got connected. And if I now send information to the ESP32, then we see here guitar information, and we can send that a whole lot of times. In between though, you see that the ESP32 is showing here the random number 1 and random number 2 that it's actually sending over to the client. And that of course is because we in the code printed the JSON string in the main loop. So you can just comment that out if this is annoying for you. All right, so with that, we now have communication from the client to the ESP32 and vice versa with very comfortable JSON strings where you can just add as many variables as you want. And this is really ideal if you have sensors out in the field and you want to have a web page showing everything directly on that ESP32, or if you have maybe a lot of stuff that you want to send from your clients to the ESP32 at the same time, maybe configure stuff through a web page or so. Have fun with this. And join me in part 3, where we'll focus on communication between ESP32s. For that, Wi-Fi can be used as a very fast and reliable medium, and you don't need to set up a web server, and you don't need to have a router for that. As usual, likes are well appreciated, leave comments down below, and see you in part 3.